I'm going to part B. Part B is Z2, which is given as -2 plus 2i. The first step is always to draw the Argand diagram, which we know already. So if this is my Argand diagram, this is the real part of the complex number Z2. This is the imaginary part of Z2. Now what do? We need to indicate on the horizontal axis, which is the real axis, we have -2. This is our origin. We have here -2, then here we have +2 on the real axis. On the imaginary axis, we have +2. So this is my +2, this is the corresponding -2. After that, that is the complex plane. Let us now get the point of intersection of -2. This -2 is on the horizontal axis, which is the real axis, which is here. +2 is on the vertical axis. That means -2 and +2, they are going to intersect somewhere here. They will meet somewhere there. So you get your ruler, draw a straight line joining the point of intersection and the origin. Then you mark it as, this is your complex number Z2. You can mark it outside here. This is complex number Z2. Now, how do we get the argument? Now, the argument is the angle which we are going to measure from the positive x-axis up to where the complex number is. Up to that part where the complex number is. Now, that gives us the angle that we are looking for. But now, we know that already from here up to here, this one is 90 degrees already. This is from here up to here is 90 degrees. So what we just need to do is to get this angle here, so that we add it to 90 and it gives us the argument. I don't know if you are getting it, because here we already have 90. So to 90, because from here up to here is 90. Now to 90 we need to add this other part so that we get the complete argument. So for us to do that, we need to extract a very small triangle from there that will assist us to find the angle which we add to 90 degrees so that we get the argument. Now there are very many ways, there are very many approaches getting that small angle which we shall add to 90 degrees and gives us the argument. There are very many. Let me do it in this manner. I'm going to extract this small triangle that is here, here, and here. And to draw it how it is looking, it is having dotted lines there. This one comes vertically down. Then there is that one. I'm extracting this here, and then there. That is what I'm extracting. So that means this is the angle that we are looking for. This one is the angle we are looking for. And from here up here is 2 units. So this side is 2. This is where our right angle is forming. This is where the right angle forms. And then from here up to there will again force us to find from here up to here. You can find the magnitude of the complex number to give you that side. But now you already have from here up to there as -2, which is this side. You can take it as +2. So let's look for this angle here. Let me call it maybe beta. Let me call it beta. Now, if you look at this, this is the angle. So opposite with the angle here we have 2. So this side is opposite. This side is opposite because it is opposite to the angle that we are looking for. This side is hypotenuse because it is the longest side. And then this side is the adjacent to the angle. Adjacent. Now what do we have? We have the opposite and adjacent. We have the opposite and adjacent. And if you apply SOHCAHTOA, This is for sine, this is for cos, this is for tan. We have the opposite and adjacent. Since we have the opposite and adjacent, we shall apply tan. So here we shall say tan of our angle, which we are calling beta, is given as opposite out of the adjacent, which is equal to, that means here tan of beta. What is the opposite? Opposite to the angle is 2. Also adjacent to the angle is 2, which gives us 1. That means here tan of beta equals to 1. But we are looking for beta. Therefore, we shall say now beta equals to tan inverse of 1. Then you press your calculator. Press shift tan. It gives you tan inverse of 1. It is 45. This here gives us here 45 degrees. Remember, the 45 that we are getting is only for this small section of the angle. That small section of the angle here. Now, and we say this side is 90 degrees. So now for us to find the adjoint theta. Now the adjoint theta now becomes 90 degrees plus 45 degrees. This gives us a 135 degrees. So now the adjoint of Z2 is 135 degrees. There are very many approaches to solving this, as long as you have drawn your Gann diagram. Someone could begin by getting this angle here that the complex number makes with the negative x-axis. After getting that angle, remember the whole of this side is also 90. So after getting this angle below, then you take it away from 90, and then it will leave you with the angle above, and that will still give you 45. And then you add that 45 to 90 degrees so that you get the angle which the complex number makes with the positive x-axis. In the end, the adjoint should be measured from the positive x-axis up to where the complex number is. So this is the answer, and it is correct.